Hi, everyone. Happy New Year. Hope everyone's doing well. I want to show a demo of the new feature that's included in the first update of Illuminated Cloud in 2023, effectively full end-to-end support for Salesforce Functions development in Python. Illuminated Cloud has supported Salesforce Functions development pretty much since that was first announced in the other supported languages of Java, JavaScript, and TypeScript. And this just extends that same functionality for Python as a supported language. So pretty much everything is going to be the same if you've ever played with the functions support in Illuminated Cloud so far, except for, of course, the language. And one other thing that I'll mention as we get into the actual demo. One thing I do want to say on the front end is as far as JetBrains IDE support for Python, first class language support for Python is available in, of course, PyCharm, all editions of PyCharm. That is their Python IDE, and IntelliJ IDEA, all editions. So that includes the free community edition, of course, Ultimate Edition. You do have to install the respective Python plugin, and they effectively give the analogous support in the respective PyCharm edition. So IntelliJ IDEA Ultimate Edition is going to have the functionality of PyCharm Professional, and IntelliJ IDEA Community Edition, the free edition, is going to have the same level of support as PyCharm Community Edition, the free version. So the other IDEs, WebStorm, RubyMine, PHPStorm, are not going to have first class Python support. You can still develop Python functions, but you're not going to have interactive debugging or really rich editor features, those types of things. So I would recommend if you're using one of those IDEs, you go grab PyCharm Community Edition or something like that if you want to play with Python functions. All right, all that preface out of the way, let's go ahead and dive in and take a look. All right, so the first thing I want to do is go straight to the Salesforce Functions dashboard. As shown in the previous demos of functions, this is the main hub for creating, managing, launching, monitoring your functions in all languages. You can see I've created functions in all the different languages, including Python. So we could double click on this Python function and we could see an implementation as generated by the Salesforce CLI, the SF CLI, when the actual function was originally generated. Very simple. All it does is queries accounts, logs the number of accounts that were returned, and then returns to the caller a JSON serialization of that. Obviously, any real function is going to be much more complex, but it gives you an idea what a Python function would look like, and its inputs, basically the event in the invocation context. So why don't we take a look at what it means to create a function in Python, to start it so that it can receive invocation requests, actually invoke it, debug it, things like that. So we'll just go down here and we'll say new function. You can see the standard create Salesforce function dialog, and you can see that Python is now an available language. So we'll go ahead and call this a demo function. I could change the other attributes. I'll just go ahead and hit enter. And what it's going to do is use the CLI to actually stub out that function directory as a subdirectory of functions over here alongside the other ones. And now that that's done, you can see some other things happening. So because I'm in IntelliJ IDEA Ultimate Edition with full Python support, Illuminated Cloud is now telling the IDE about this function, setting up an SDK, setting up requirements like the Salesforce Functions Python library so that you can actually do things like query and DML, things like that. So you can see that there's full code completion now. That's done. It's tied all that together. There's full code completion. I can run a query. You can see that it knows when a query gets executed that the string literal that's handed to it is a live query. It's going to give you full SOQL code completion, syntax validation, all those types of things. So if we want to add account number there, we could go ahead and add account number. So pretty much a full ID. If we want to, just one other thing I'll show is you get integrated API documentation. If I wanted to, use refactoring, I could use refactoring and extract an expression. The full capabilities of the host IDE and its support for Python are available here, tied into the Salesforce environment and its functions execution. So speaking of execution, what if we wanted to execute this function? Well, you can see that it's added a gutter icon that actually gives you some actions. And I typically try to do everything from the keyboard when possible. I find it to be faster. So I'm going to use context actions, Alt-Enter on Windows or Linux, Opt-Enter on a Mac. It's going to show the same things. I'm going to go ahead and say I want to debug this. So I'm going to hit Enter, and it's saying that the function's not yet running, which we can see down here in the dashboard. Excuse me. Do we want to start it? Well, we have to. So I'm going to go ahead and start it. Started on default port 8080. This is the other difference that I had mentioned earlier, alluded to earlier. You'll see that the debug port is disabled. I can click use container, in which case it would start it in a Docker container. But if you try to start it truly locally, you'll see the debug port is disabled, as is the verbose option. And the reason is there is no standard remote debugger for Python like there is for Java, for JavaScript, for TypeScript. So when you start one of these locally using the SFCLI, it's not available for remote debugging. So if we want to debug it remotely, we have to do something else. And that's exactly what Illuminated Cloud does. And so if we hit OK, it's actually going to execute this function as a Python script using its native Python script debugger. And so that's what's happening. It's already started that, and then it invoked it using the CLI. So it basically passed in an empty payload. No payload is being used here. And we can see the JSON serialized output. We can see the one account that's in this scratch org. And if we go to run, if we go to debug and go over here to the actual function and look at the console, we can see the logged output from where this executed. Function successfully queried, basically the result set size account records, and we can see that it queried one account record. So that's great. So now we can actually start a function, invoke a function, see the logged output of that function. One other thing I'll show real quick, going back over to the functions dashboard, is whereas the logged output of the running function would have been shown here in the local execution console, because of this slight difference, it's going to redirect you to the debugger up here. One other thing I'll point out real quick, you may find that my screen my IDE layout doesn't look like yours. And the reason for that is I'm using the new UI that started with 2022.3. I've got it enabled here, and I turn on the menu bar. I could turn that off and it would look like it did prior to 2022.3. I'm keeping it on for a variety of reasons. I've talked about those in some release notes. But the point is, if you're seeing things as being slightly different, that's why. Everything still is in the same general place. But for example, the tool window strip is going to be down the bottom left side instead of across the bottom. And of course, you're going to see some differences in just some of the cosmetics, just in case that stood out to you. All right, well, let's go ahead and move on. So we can get logged output. That's great, and that helps certainly with one level of diagnostics, but let's try to use the interactive debugger. And so I'll set a breakpoint right here after the result set has been generated. And let's just say that we want to debug this again. I'm going to go back over here and I'm going to tell it to run. Run being because just run the invocation. The function is already set up for debugging. So I'm going to run, it's going to invoke, and as soon as that invocation takes place over port 8080, we should actually hit this breakpoint right here, and we did. And so we can see the parameters that were passed into the function. We can see the stack variable from actually executing the query. We can see the results of that query, one row. Here are the field values. And to be clear, this is an interactive debugger, not a log-based debugger. So we can do all the fun things you can do with an interactive debugger. We can do complex real-time expression evaluation. We could set up conditional breakpoints. We can set up dependent breakpoints. Really everything that you want to be able to do. We could pop stack frames and change values and then basically continue to step in. And so we'll go ahead and just step over and we'll step out of this executing function. So if we go back over to the debug window and we go back to our console here, we can see it's now been invoked twice. That second time was when we just did that for debugging, but we can see that it's actually been invoked twice. If we go back to the functions tool window, we can look at the running details of it. We can see it's running on port 8080. We can see that it actually is running. If we wanted to, we could restart it. We can stop it, whatever it is that we need to do. We'll go ahead and stop the function just to show some of the things that you can do. Something else that probably makes sense to talk about is third-party dependencies. If you're going to write any real function, you're almost certainly going to pull in some third-party libraries. And so if you go to this function and take a look at its requirements.txt, this is going to be analogous to your package.json for JavaScript and TypeScript used by Node, or your pom.xml used by Maven for Java. And so you may notice that there's not a unit test generated here. That's because this function is still in very early beta. Or rather, support for Python functions in very early beta. I'm sure in one of the upcoming builds between now and GA, there will be stubs generated for unit tests for your functions like there are for the other supported languages. It's not there right now, but once that's there, let's say that you wanted to express a dependency on PyTest, or that will probably be out of the box, or any other third party, you can see that the IDE intelligently realizes that you've expressed dependencies that have not actually been installed. So you can just have the IDE go ahead and take care of that. Again, this is analogous to what happens with the other supported languages and their third-party dependency management mechanisms. Just want to show that it's a really full end-to-end development environment for Python tied into the Salesforce ecosystem and Salesforce Functions capability. And if we wanted to, we could even delete that function. Before we do that, we'll show that it's added all this to version control. I've got this set up against Git right now. It's added these files to version control. I could go ahead and check these in, but if I delete the function, it is going to clean up everything that it needed to clean up. So I'm going to go ahead and say, yes, I want it to delete the function. And if we go back to version control, we can see that all of the scaffolding of that function has been removed, including the SDK it created, the module, all of that. So basically, it does a complete job of managing the IDE infrastructure in terms of the project, the dependencies, and all that. So that's really what I wanted to show. Like I said, this is effectively an extension of the previous demo for functions that showed a more broad overview, including deployment to a remote compute environment and all that. I didn't show that here because I basically want to focus on the differences with Python language support, and hopefully I've done that. Please go play with it. If you find any issues, anything that's not working as expected, anything you think could be more efficient or could stand room for improvement, let me know through the public issue tracker. Reach out directly and let me know. I'd love to have the feedback. Otherwise, thank you very much for your time, and take care.